Dear students, today you are going to learn what is Cauchy's residue theorem and how to evaluate problems by using Cauchy residue theorem from unit 4. So before evaluating problems under Cauchy residue theorem, first you must understand how to evaluate this simple problem. How to evaluate this already you studied in previous unit itself. To evaluate this integral, we need only two formulas. One is integration of x power n and another formula is integration of constant. You know what is integration of x power n? What is that? X power n plus 1 divided by n plus 1. And what is integration of constant? Integration of constant is integral c dx, which is equal to c into x. The c is constant and dx is integrating variable. So c into that integrating variable. Now apply this formula. Integration of z square is z cube by 3. This 3 is constant, you must keep as it is. And integration of this 4z is 4 into z square by 2 minus integration of this 2 is 2z, and this plus c for indefinite integral because they are not given what is c. Now simplify this. After simplification you got this answer. Now look at next problem. How to evaluate this problem? You look this question, integral over c z plus 3 divided by z plus 2 into z plus 1 whole square dz. Actually in differentiation we have a formula like quotient u by v, quotient rule, and product rule u into v, like we have in differentiation. But in integration we have the product rule u into v, like Bernoulli formula or integration by parts. But for quotient function we don't have any direct formula in integration. To evaluate this type of integral, you need to study what is Cauchy's integral formula and what is Cauchy's residue theorem. Already you studied what is Cauchy's integral formula in previous topic that madam taught you, and in today's topic you are going to learn what is Cauchy residue theorem. So understand it. To evaluate this type of problems, that is fraction of functions or quotient of functions, we don't have a direct formula. Like previously we solved one problem, that problem we can integrate it directly, but for this type of questions we don't have any direct formula or direct method. So to evaluate this type of problem you must study what is Cauchy's integral formula and what is Cauchy residue theorem. Only these two methods you have in your syllabus to evaluate this type of problems. Now how to evaluate this integral by using Cauchy residue theorem? Before doing problems you must understand what is Cauchy residue theorem. Now look at the statement. What is statement of Cauchy residue theorem? If f of z is analytic in a closed curve C except at a finite number of poles within C, then integral over C f of z dz, which is equal to 2 pi I times sum of the residues of f of z at the poles which are inside C. Now look this diagram. This C, the C is nothing but the circle, the bigger circle. What is pole in this? Pole is nothing but there are small circles inside this big circle C. The center of each small circles are called poles. So if you want to evaluate any integral like this, you must find residue, that is 2 pi I into sum of the residues of f of z at the poles. So you must find residue, then sum it. So before finding residue you must find pole. Without pole we cannot find residue because pole is the base. So after finding pole, based on the pole order we can find residue by using formula. So you must find poles first, after that go for residue. Then after finding residues just sum all that residue, that gives you this corresponding value, integral value. You look this object, this oval shape object is called C. In Cauchy residue theorem, C is nothing but this oval shape, whereas the poles are nothing but inside this oval shape we have small circles, many circles we have. The center of each circle are called poles of the function f of z. What is pole? The center of each small circles which are lies inside this oval shape. They are called poles. Now I am going to explain you how to evaluate any complex integral by using Cauchy residue theorem. Step by step procedure I have given here. Just refer this. Step 1. To find the poles of the given function f of z. The integrand of given question. The integrand of given question is known as f of z. First you need to find poles of the given function f of z. How to find poles? It's very simple. Just denominator of the f of z equate with 0. How to get f of z? It's integrand of the given question. Just denominator equate with 0. That gives you poles. After solving the denominator equate with 0, after solving it, you'll get the values of z. They are called poles. Step number 2. Check what are the poles inside C. You need to check what are the poles inside the given C. The C may be, most of the time it's circle, sometimes maybe some other shape also, but it must be close to 1. Okay. Step number 3. What is step number 3? To find a residue of f of z at the poles which are lies inside C, completely lies inside C. What is step number 3? To find residues of f of z at the poles which are lies inside C. You need to find residue only those poles inside C. Sometimes you may get some poles which are lies outside. That you don't need for that poles you don't need to find residue. How to find residue? Residue by using formula. That formula I'll explain you later. Now last step. Apply Cauchy's residue theorem. You know, just now you studied what is Cauchy's residue theorem statement. Integral over C f of z dz, which is equal to 2 pi I times sum of the residues of f of z at the poles. So remember it. If you want to find residue, first you need to find poles first. How to find poles? Denominator equate with 0. After getting poles, check what are the poles inside C. Find residue corresponding to the poles, those poles inside C. So first we need to find poles. After that you can find residue. After finding residue of the given question, just sum it, multiply with the 2 pi. That gives you answer for the given question. So I'll repeat again. What is step number 1? To find poles of the function f of z by equating denominator of the function with 0. Step number 2. What are the poles inside C? That you need to check by substituting the poles in the given C. Step number 3. To find residue by using formula. You need to find residue only for the poles which are lies inside C. And finally apply Cauchy residue theorem. What is theorem statement? Integral over C f of z dz, which is equal to 2 pi times sum of the residues of f of z at the poles. This is the basic concept. We'll learn problems in next videos. Thank you.